In this lesson, we are going to be talking about functions and algebra, so let's get started. So the first thing you gotta know for math counts when it comes to algebra, other than polynomials, is just functions. And when it comes to functions, these are the most common type of algebra problems you're going to see in math counts. Polynomials are not as common as you see functions. However, polynomials are very important. We usually define a function as f of x, where x is the input and f of x is the output. So basically, let's say I have a function f of x is equal to x plus 1. This is basically saying for every value of x, there is one output, f of x. So if I put in x is equal to 1, that'll be f of 1. And I solve, that's going to be 1 plus 1. So we can conclude that f of 1 is equal to 2. It's basically a function. And you can change this f, you can change it, you might get like n of x, you might get g of x, h of x, you can have lots of possibilities. Just know that this is your function notation in case you aren't familiar with it. So you plug in your value and solve. Let's say I had something like, I'm going to give a look at example. Let's say I had f of x is equal to x squared plus 1 and evaluate f of 10. This problem is all a deal of understanding function notation. If we plug in x is equal to 10, in this problem we have 10 squared, which is 100, plus 1. So we can conclude that f of 10 is equal to 101. Now, let's look at something a little bit different. Given that f of x is equal to x squared plus 1 and h of x is equal to, let's say, x squared minus 1. And then you might have a problem where, let's say, you're asked to evaluate f of h of minus -1. Evaluate this given the function rules given. I'm going to split our problems up so you can see what I'm talking about. So we work from the inside out. We start h of -1. If I plug in x, -1, I'm going to get, and I'm going to split this up into two separate problems. I'm going to have h of -1. If I plug in -1 squared, that's 1. I have 1 minus 1, which is 0. And now I'm going to evaluate f of h of -1. h of -1 is 0. So that means I'm going to be evaluating f of 0. If I plug in 0 over here, 0 squared is 0. That means I have 0 plus 1, which is 1. And our answer is going to be f of h of -1, which is f of 0, which is 1. So this is just 1. So whenever you have multiple things like this, multiple functions that you need to evaluate, always work from the inside out. That is something that you should know. Now let's move on to a different type of function, which this is probably the most common type of algebra problem in math counts. Let's say the operation, let's say we have an operation, a new operation. I made up an operation which instead of using division, multiplication, addition, or any other mathematical notation, I like to use a star. So if I have an operation A star B is equal to A minus B times A plus B, what is the value of 5? Let's have 5. It's a bad star. 5 star 4. Just evaluate 5 star 4 is our problem. So we have another star 4. Evaluate 5 star 4. Now over here we know that A star B is equal to A minus B times A plus B. Here we let 5 equal to A and set B equal to 4. Now we just plug in our values and solve. So we have 5 minus 4 times 5 plus 4. And I'm not going to expand this product because it's easier to just evaluate in the factored form. Now I have 5 star 5 minus 4. Well, 5 minus 4 evaluating, we have 1 multiplied by 5 plus 4, which is 9. So we get 5 star 4 is simply equal to 9. Now this is how you evaluate such a problem. You plug in your values and solve accordingly. It's as simple as that. Let's try another example. If the operation A I have my new, let's say I made up some sign. The operation A, the symbol B, is defined as A minus B plus 1 what is the value of 5 the operation 4. Now the same thing happens. We set A is equal to 5 and then we set B is equal to 4, and now we have 5 the operation 4 multiplied by 1, and then we add the 1 on, which means this is equal to 1 plus 1, which is just 2. Another example of special functions. Now, this is just an extended form of functions. We're doing the same exact thing. We're just changing we're not using the function notation as we used it here. We're changing it up. Now let's go on to the problems. All math counts problems. If g of x is equal to 2x squared minus 3 and h of x is equal to 4x cubed plus 1, what is the value of g of h of negative 1? We have g of h of negative 1, and we have g of x is equal to, we have h of x equal to 4x cubed plus 1. We evaluate from the inside out. H of negative 1, we have h of x is equal to 4x cubed plus 1. H of negative 1, we plug our values in. H of negative 1 is just equal to 4 multiplied by negative 1 cubed plus 1. We evaluate the cube. Negative 1 cubed, well, that's negative 1 multiplied by negative 1. That's 1. 1 multiplied by negative 1, that's negative 1. So that's 4 multiplied by negative 1, which gives us negative 4 plus 1. So h of negative 1 is negative 4 plus 1. That gives us negative 3. Now to evaluate g of negative of g of h of negative 1. H of negative 1 is 3, so we're evaluating g of negative 3. Now we know g of x equal to 2x squared minus 3. Well, g of x is equal to 2x squared minus 3, so we have g of x is equal to 2x squared minus 3. Now we plug in our values. G is negative 3. Negative 3 squared, that's negative 3 multiplied by negative 3, that's 9. We have 2 times 9, which is 18, minus 3. So we have g of negative 3 is just equal to 18 minus 3, which g of negative 3 is 15. So our value, evaluating, we get g of h of negative 1. H of negative 1 is negative 3. G of negative 3 is 15. So the answer is 15 to this problem. Let's move on to the next problem. Let the operation m to asterisk n be defined as m asterisk n equals m minus n, entire thing squared, divided by m plus n, square the entire binomial for all real values of m and n. What is the value of 100 asterisk 50? Expressing our answer as a common fraction. So on our answer in a common fraction, we have our function defined. 100 asterisk 50. Let's do the same thing here. Let's plug in our values. Let's let m is equal to 50 and set n is equal to 50. M is equal to 100 and set n is equal to 50. So we have plug in the values for the output result, which is m minus n squared 100 minus 50 squared divided by 100 plus 50. We square it. Now 100 minus 50, that's 50 squared. 100 plus 50, that's 150 squared. Now 50 squared, 5 times 5 is 25. We have 2 zeros for the square. That's 25, 2,500. Now 150 squared. 15 squared is 225. And we have 2 zeros for the square, so we have 225. Now we have this common fraction. We want our answer in the simplest form. Zeros cancel out. We have 25 over 225. And this eventually simplifies down to 1 over 9. So we can conclude that 100 asterisk 50, and I forgot one asterisk over here, 50 is equal to 1 over 9. Plug in your values and we got our results. As easy as that. Now the next problem is going to require some strategy. What digit is represented by triangle if 144 divided by triangle is equal to 1 triangle with 1 the tens digit and triangle the tens digit of the quotient? This is known as number theory, as algebra mixed with number theory. Essentially, we're dealing with a number theory problem, but we also have algebra with it. We have triangle, which can be represented as a variable. We don't like to call it x or something because we're not multiplying 1 by triangle. It's a digit. Right, so what digit is represented by triangle? Well, we have 144 divided by this triangle is equal to 1 over the triangle. The digits are the same. So this means when we're dividing, we're going to be dividing something by 144. When we're dividing this out, essentially 1 triangle 144. Well, if we want something divided by 144, we're going to have a triangle over here. And this triangle needs to go into 144 such that this goes into 14 once. Right? This needs to go into 14 once to build that first digit. And then it needs to build the triangle digit. So we're going to solve this by strategic guess and check. So I'm going to start off by placing values of the triangle and dividing it by 144. Now, we know that 6 times 2 is 12. That won't go into 14. 5 times 2 is already 10. We already know anything less than 5 won't go in. 6 won't go in. 7 times 2 is 14. That builds a 2. We don't want a 2. Now we look at 8. 8 times 2 is 16. So obviously 8 goes into 14 once. That's the least. So we're guessing that's 18. I mean 8. Triangle is 8. Let's test. 8 times 1, it's 8. 8 times 8 is 64. Let's see if this is true. Let's plug in the value of the triangle. We have 144 divided by the triangle, which is 8 in this case, is equal to, and in this case, it's not supposed to be divided by, it's supposed to be equal to 1 over the triangle. One triangle, with triangle being digit, not a division problem. So we have 18, and this is equal to 18. Check it out. The triangle digit is the same thing. So the digit, we can conclude, is represented by 8. It satisfies the relationship over here. Henceforth, we plugged in our values, used some guess and check, and got to our answer.